everyone, welcome back. Today we're going to be looking at exponents, and the standard we're working with is 6.ee.a1, which is to write and evaluate numerical expressions involving whole number exponents. So let's take a look at our vocabulary terms. Exponents, which is also sometimes referred to as a power, shows how many times the base should be multiplied by itself. The base, represented by big B here in this image, is the number that is being raised to a power or that's being multiplied. So for example, b raised to the n power, we would read this as b raised to the nth power. Okay, now this means that I'm going to multiply b by itself n times, whatever n represents as a number. So when we look at this here, we have this big 4 and this small 3 up top. This is what we call an exponent. So 4 would be our base and 3 is our exponent. We would refer to this as 4 to the third power or 4 cubed. Anytime you have an exponent of 3, we refer to that as cubed. Now, when we have an exponent of 2, we call that squared. So 5 squared or 5 to the second power. Any number to the 0 power is 1. So this is a rule that you just want to memorize. And I'll explain to you a little bit later why any number being raised to the 0 power will always be 1. Any number to the first power is itself. So if I think 2 to the first power is going to be 2, 5 to the first power, any number, 100 to the first power, is just itself, 100. Here we should have a 4 to the third power. I'm not sure what happened to our image. 4 to the third means 4 multiplied by itself 3 times. So we have 4 times 4 times 4. Powers of 10 will only contain ones and zeros. Okay. Now let's go ahead and take a look at a few examples. So here it's asking me to explore the number, identify the base, the exponent, expanded form, and standard notation. Now here, expanded form just means that I'm going to write out how many times a number is being multiplied, and then standard notation is my answer. So if we look at the example that's provided for us, we have 6 squared, the base is 6, the exponent is 2, and to expand 6 squared, it's going to be 6 times 6. Now, when we do our multiplication, 6 times 6 is equal to 36. That's our standard notation. Let's go ahead and try 2 to the third power. This is a good place to pause the video and try one on your own, or you can do it a little further down. So the base for 2 to the third power is 2. The exponent is 3. Now, how many times are we multiplying 2 by itself? We're multiplying 2 by itself 3 times. So I'm going to represent that here. 2 times 2 times 2. Now, my standard notation is actually the product of that. So 2 times 2 is 4. 4 times 2 is 8. So 2 to the third power in standard notation is 8. 2 to the third power in expanded notation is 2 times 2 times 2. Now, this example is asking us to work a little bit backwards. So it gave us the expanded notation and wants us to fill in the other values. So now I know if I'm multiplying a number by itself twice, that's going to give me an exponent of 2. And the number that's being multiplied by itself is our base. So that's 7 squared. 7 times 7 is 49. That's a perfect square, similar to 36. Now here we're given our base and our exponent. We can put those together. That's 4 squared. And then when we write it in expanded notation, we have 4 times 4. 4 times 4 is 16. That's another perfect square, right? Which makes sense because the number is being squared. 5 squared gives us a base of 5, an exponent of 2. Again, you can feel free to pause at any time and try these examples on your own. And that's 5 times 5, which is 25. Now I have 3 being multiplied by itself 3 times, so that means I have an exponent of 3, and my base is also 3. Okay, A common mistake that a lot of people make when they're looking at exponents is that they say 7 times 2 or 4 times 2, 5 times 2, but that's not what it's asking you to do. It's asking you to multiply that number by itself however many times. Okay? Now 10 to the fourth, our base is 10 and our exponent is 4. So that means we're going to multiply 10 by itself, not 10 times 4, but 10 by itself 4 times. I'm going to try to squeeze that in here. Okay. Now here we have a base of 10 being raised. The good thing about when we have a base of 10 is that we can just actually add the number of zeros that's being multiplied. So 10 times 10 is 100. Okay, so I have 2 zeros. 100 times 10 is 1,000. I have 3 zeros, and 1,000 times 10 is 10,000, which gives me 4 zeros. Okay, so if you notice, our exponent will match the number of zeros that we have in our final answer, and you can pretty much rely on that all the time. I just realized we didn't do the standard notation for 3 times 3 times 3, so let's go ahead and do that. 3 times 3 is 9, okay, and then 9 times 3 is 27. All right. Now let's talk about why anything to the 0 power is 1. So let's take a look at this pattern and then we can identify what's happening. So 2 to the third means 2 times 2 times 2, which is 8, right? 2 times 2 is 4, 4 times 2 is 8. 2 squared is 2 times 2, which is equal to 4. And then anything to the first power is just itself. Now, can you identify what is happening between the 8, the 4, and the 2? Like what's happening? What's the change in the pattern? Go ahead, think about it. If you said that we're dividing by 2, then you are absolutely correct. So 8 divided by 2 is 4. 4 divided by 2 is 2. Now, what about if I divide 2 by 2? Then the next number in our series would be 1. And if I continue that pattern, so 1 divided by 2 is 1/2. So there, I'm partially introducing you to a negative exponent. When I go into my negative exponents, I'm going to end up with fractions. And that's because if I continue my pattern of dividing, I'm going to end up with fractional numbers, okay? And if you notice, the number that we're dividing by here just happens to be the number that's associated with our base. Don't believe me? Try another example. Let me squeeze one in here just so you can see it. So let's start with 3 squared is 9. Then 3 to the first power is 3. Now what would be 3 to the 0 power? Believe me now? 9 divided by 3 is 3. 3 divided by 3 is 1. So anything to the 0 power is 1. Let's take a look at some other examples. 12 to the 0 power, it's just going to be 1. Now here we have operations that are involving our exponents. Whenever you see this scenario, you want to evaluate each term. So 9 squared is one term, and then 4 to the 0 power is another term. So identify each term, evaluate them, and then combine using whatever operation is listed. So 9 squared is 9 times 9, which is 81. And then 4 to the 0 power is 1. So now we're left with 81 plus 1 for a final answer of 82. Now 8 to the negative 1. So as we saw earlier, that when I get to a negative 1, it's going to end up being a fraction. And that's going to be 1/8. So I'm literally taking the reciprocal. I'm flipping this whole number and make it into a fraction, because this is like saying 8 over 1. And it becomes a fraction, 1/8. Do you want to see another example like that? Let's take a look at it. Let's say we have 5 to the negative 1 power. As long as it's to the negative 1 power, it's just going to be that reciprocal. So again, this is like 5 over 1, so that will become 1/5. We will not make the number negative, okay? the exponent was negative, and with negative exponents, based on our pattern here that we followed, we see that the number becomes 1 over 5. Okay. And if you think about this, it's like your number line, right? So 3, 2, 1, 0, and then it ends up into our negative realm. Sarah listed the prime factors of 72 as 2 times 2 times 2 times 3 times 3. What is another way we could represent these factors? Explain. So first off, let's check to see if Sarah is indeed correct with her prime factors. So remember in our previous lesson, we talked about for prime factors, you want to start with the smallest prime number that goes evenly into 72 and its factor pair, and then we're going to continue to break down in that way. So the smallest prime number that goes into 72 is 2. So 2 times 36. Oops, I shouldn't have circled that. 2 times 36. Then I want to break down 36 even more. I'm now going to use 3 and 12. So 3 I'm going to circle, and then I'm going to break 12 down even further. I'm going to use 3 and 4. And then 4 I'm going to break down to 2 and 2. So here I have 1, 2, 3 twos. So 2 times 2 times 2. And then I have 2 threes. Okay. So based on what I have, it matches what Sarah did. So we can say that her answer is indeed correct. Now let's think about representing this using our exponents. So now let's go ahead and think about how can we rewrite this using another method, right? And what method are we learning about right now? Exponents. So let's try that. So here I have the number 2 being multiplied by itself 3 times. So I can represent 2 times 2 times 2 as 2 to the third power. And I can multiply 3 times 3 as 3 squared. So here I have 2 to the third power, or 2 cubed, and then I have 3 squared. Now, let's look at what operation is happening in between these. So the 2's are being multiplied, I represent that here. The 3's are being multiplied, I represent that here. And then I'm going to bring down that multiplication symbol. Now, could I have represented this as 2 to the 5th power? No, because I don't have 5 2's. I cannot combine my 2's and my 3's with the same exponent. I have to represent them separately. Okay. Now, let's go ahead and just check to see if our work is indeed correct. So 2 to the third power is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And then 3 times 3 is 9. What is 8 times 9? 72. Yep, that is correct. Now let's take a look at powers of 10. How can you express 10,000 using exponents? So if I have 10,000, how many zeros are represented here? 1, 2, 3, 4. So based on our previous example, we know that the number of zeros represents our power, right? So I can represent this by saying 10 to the 4th power. So I have 1, 2, 3, 4 zeros. That represents my exponents, and my base is 10. Okay, you want to prove it? Let's do it. So 10 times 10 times 10 times 10. 10 times 10 is 100. So that's 2 zeros. Times 10, that's 1,000. Times another 10 is 10,000. Okay. Now, how can we write 10 cubed in expanded form? So remember we talked about cubed representing an exponent of 3. So 10 cubed is 10 to the third power. And in expanded form, that's just going to be 10 times itself 3 times. Okay, so we've just written it in expanded form. And now for standard form, we need to actually complete the multiplication. So 10 times 10 is 100 times 10, and 100 times 10 is equal to 1,000. So 10 to the third power is 1,000. How many zeros do I have? 1, 2, 3. It matches my exponents of 10 cubed. Thank you for watching and have a wonderful day.